In this series of videos, I'd like to talk about integration by substitution. We might call integration by substitution the chain rule for integrals because we use it to find antiderivatives of function composition, just as we use the chain rule to find derivatives of function composition. If you recall from your work with derivatives that the derivative of the function composition f of g of x is equal to f prime of g of x times g prime of x. Or we take the derivative of the outside function f and it becomes f prime. We leave the inside function alone, so we get f prime of g of x. We multiply that by the derivative of the inside function, which is g of x. Its derivative would be g prime of x. So we get f prime of g of x times g prime of x. Well, then it should also hold true that its integral should bring us back to where we started from. Since integration is the reverse operation of differentiation, the integral of f prime of g of x times g prime of x dx should give us f of g of x plus c. So let's take a look for a minute at why that's true and how we can demonstrate that in fact it is true. And we can learn by this demonstration a technique we can use to work with similar types of integrals. Well, starting with this integral, f prime of g of x times g prime of x dx, if we let u equal the inside function g of x, and we take the derivative of u with respect to x, then obviously du dx is equal to g prime of x. If we write that in differential form, so that du is equal to g prime of x dx, then you'll notice that that is precisely what we have on the right, in the right part of our integral, g prime of x dx. So we can substitute that for du. Now if we were to rewrite, we have actually swapped out anything to do with the variable x, and we have rewritten this integral in terms of u. And in so doing, we have simplified this integral to a great extent. And finally, we know that since integration reverses differentiation, the integral of the derivative of f of u with respect to u is simply just f of u plus c, of course. Swapping out the u again for g of x, we get that integral of f prime of g of x times g prime of x dx is simply equal to f of g of x plus c. Now, even more than demonstrating that this in fact does work, this technique, this procedure, is going to allow us to integrate expressions of the form that we see here. And what is that form? Well, these are particular types of integrands that have the following characteristics. First of all, it involves function composition. And in our original integrand, we have f prime of g of x, so we have function composition there. Second of all, the derivative of the inside function g of x, and that derivative is g prime of x, it shows up on the outside of the function composition and is multiplied times or by the function composition itself. And when those two things are in place, we can use the technique that we just saw to find the antiderivative of that complex expression. Now we will see examples of where this does not always involve function composition, but it is one of the primary characteristics of these types of expressions. We'll have function composition, and the derivative of the function on the inside is multiplied times the function composition on the outside. And we'll take a look at some examples of that in the coming videos.